Hey guys, Jake here, coming at you with another math lesson today. Today we're going to continue our discussion of mastering limits and continuity from the Elite Guide to AP Calculus AB. We're going to be going through this problem here. We're going to evaluate the continuity of the function f of x at x equals 2 based on this piecewise function for f of x, where we have x squared plus 2 as our function for x greater than or equal, or less than or equal to 2, or 2x for x greater than 2. So if you're interested in checking out my new book, The Elite Guide to AP Calculus AB, you can scan that QR code up in the upper right-hand corner of your screen, or you can check out the link down in the video description or the pinned comment below. But let's go ahead and jump into this problem. So before we go ahead and start with kind of how to set this problem up, I want to first just kind of briefly touch on continuity in general. So in general, in order for this function f of x to be continuous at x equals 2, what we would need to make sure is true is we would need the limit as x approaches 2 to be of this function f of x to be the same as what we would get by just simply plugging 2 into the function. So this is kind of the definition of what it means for a function to be continuous at 2. In this case we have 2. If you want to change the 2 to any other number, just make sure the limit as x approaches that value of your function is the same as whatever output you get from just plugging that value into your function. So whatever this 2 is could change, but this is the general kind of definition of continuity at a certain x value. So what that means in this case, we need to make sure that the limit as x approaches 2 of this piecewise function is the same as what we get by just plugging 2 into this piecewise function. So let's think about what that would give us in this case. So first of all, this f of 2 is usually going to be a little bit easier to find, so I'll start there. In order to evaluate this function f of x at x equals 2, it's a piecewise function, so we need to first figure out which piece of our piecewise function we're going to be using. Since we use this piece right here for x less than or equal to 2, that tells us when x equals 2, we're going to use this piece. So in order to evaluate f of 2, we're going to use x squared plus 2 as our function. And then we would just plug 2 in for x. So that would give us 2 squared plus 2, which would be 2 squared is 4, plus 2 is 6. Okay, so then the other piece of this is we need to find the limit as x approaches 2 of f of x. Well, in this case, since we have a piecewise function as our f of x, and on top of that, this limit as x approaches 2 is looking exactly at the x value where we switch from one function to the other, that tells us that we're going to have to actually break this two-sided limit into each one-sided limit. So the left-hand limit and the right-hand limit. So instead of just finding this limit as x goes to 2 of f of x, we're actually going to need to verify, does the limit as x approaches 2 from the left of f of x equal the limit as x approaches 2 from the right of f of x, and are those two values also equal to f of 2? So basically we're going to need to find both one-sided limits and make sure that they are both 6 in order to confirm that this function is continuous at 2. So last couple videos we've been talking about one-sided limits. If you want to go check out those videos or the method that we're going to be using here, I'll put a little info card up at the top. You can click that if you want to go check those out. So I'm not going to go quite into as much detail about how to use that method, but what we can do is essentially say for our left-hand limit, I'll kind of break this out into two pieces over here. For our left-hand limit, as x goes to 2 from the left of f of x, we're going to say x equals 2 minus h, and we're going to evaluate the limit as h goes to 0 of f of 2 minus h. And since we are approaching 2 from the left, we have x values that are slightly smaller than 2, which means we need to use this piece of our piecewise function. So we're going to essentially be taking the limit as h goes to 0 of this function with 2 minus h plugged in for x. So we'll have 2 minus h squared plus 2. And this will be the limit that we'll solve. And then for our right-hand limit, we're going to do something similar. We're going to say x approaching 2 from the right of f of x. We're going to say x equals 2 plus h. And then we're going to take the limit as h goes to 0 of f of 2 plus h, which now that we're looking at x values that are slightly bigger than 2, because we're approaching 2 from the positive side, the right side, we're going to use this part of our piecewise function. So f is now going to be 2x, so f of 2 plus h is going to be 2 times 2 plus h. So the limit as h goes to 0 of 2 times 2 plus h. Okay, so we're going to have these two limits that we need to solve and make sure that are they both equal to 6. So we can start with, doesn't really matter which one we start with, but let's go ahead and just start with the left-hand limit here. So this will become the limit, and actually, I'm sorry, this actually is going to be a nice simple one that we can do kind of the easy way here. In general, the easiest way to start trying to solve a limit is just think about what would happen if you plug this value in for this variable. What would you get? If you get some sort of indeterminate form or something that can't be solved, then you know you have to do some other kind of trick basically to solve the limit. In this case though, if we just plug 0 in for h, we're going to get 2 minus 0 squared plus 2, which will give us 2 squared is 4 plus 2 is 6. So that one actually, works out very straightforward. For our right-handed limit, same idea. We can essentially just plug 0 in for h here, and if we do that, we get 2 times 2 plus 0. 2 times 2 plus 0 is 2. 2 times 2 is 4. So in this case, our left-hand limit is 6. Our right-hand limit is 4. And then the value we got from just simply plugging 2 into our function f was 6. So what we end up seeing is the left-hand limit is 6. The right-hand limit is 4, which obviously the right-hand limit does not equal the left-hand limit or the value of f at that point too. So what that essentially tells us is that since the left-hand limit and right-hand limit are not equal to each other, the two-sided limit does not exist, and therefore we cannot say that the two-sided limit equals the function at that point too. So since these three things aren't equal to each other, that tells us that this function f of x is not continuous at x equals 2. So I hope you found this video helpful. If you did, do me a huge favor, hit that like button down below, subscribe to my channel, and go check out the Elite Guide to AP Calculus AB by scanning the QR code up in the corner or checking the link down in the description or pinned comment. We'll continue our discussion of limits and continuity in the next video, so hope to see you there. Thanks and see you next time.